Hello, kids. It's another maths lesson with Mr. Daniel. Today, let us complete lesson 7 of your grade 2 Module 8 workbook. Let us learn how to interpret equal shares in composite shapes as halves, thirds, and fourths. Let us do some warm-up. We're going to use chips to model subtraction. Remember how to use chips to model subtractions? The subtrahend, that is the part you are removing from the whole, you do not draw it. You only draw the whole. And then the subtrahend, you cancel from the whole because you are subtracting. You are removing from the whole. All right, so this is 161 minus 18. If you see my chips, I've drawn 161, and then I have to remove 8 ones from 1 ones. It's not possible, so I will have to decompose 110 for 10 ones. If you look at my 110 and 10 ones, I had to decompose that and then remove the 8. When I remove the 8, I have 3 left. So my answer becomes 143 because I have to also remove 110 from the 6 tens. Remember, I've decomposed 1 already. So if you check with my vertical method, you'll see I cannot remove 8 from 1. I have to decompose 1, as I explained before. 110 becomes 11. 11 minus 3, 8 is 3. 5 minus 1, 4. I'm bringing 1 down, 143. Here's another one. 152 minus 29. I've also had to decompose 110. So when I remove the subtrahend 29 from 52, I will now have 123. The 100 remains untouched. Can you solve some for me? Let me show you another one I've solved for you. 237 minus 56. I'll write out the 237 chips. You can see all of it. I can remove 6 ones from 7, so I have 1 left. But I cannot remove 5 tens from 3 tens, so I have to decompose 100 into 10 tens. I now have 13 tens. When I remove 5 tens from 13 tens, I have 8 left. So my answer is 181. Here's another one. 319 minus 28. You write down the whole, represent the whole in the with the shapes, and then subtract the subtrahend. The one you're subtracting is to cancel out because you're removing. I can remove 8 from 9 and have 1 left, but I cannot remove 2 from 1, so I have to decompose 100 to 10 tens, and I have 11 tens. When I remove 2, remaining 9. So my answer is 291. Now solve these ones quickly. And then this application problem. Mrs. Librarian's students are picking up tangram pieces. Remember that shape puzzle that is a square but has so many shapes inside it that we can put apart each of the shape and then put them together again, tangram. Now, Mrs. Librarian's students are picking up tangram pieces. They collect 13 parallelograms, 24 large triangles, 24 small triangles, and 13 medium triangles. The rest are squares. If they collected 97 pieces in all, how many squares are there? Let us find out how many pieces altogether did they pick. They picked 13 parallelograms, 24 large triangles, 24 small triangles, and 30 medium triangles. Let's add all of that together. When you add all of that together, you have 74 shapes. But how many shapes altogether did they pick? 97 pieces. So we'll have to remove the 74 from 97 to get how many squares. Now if you remove 74 from 97, you're going to have 23. So the squares they picked are 23. Do you remember the steps we took to solve this question? Add all the figures you know of as given in the question. Remove it from the whole. All of these figures we saw, the parallelogram, the large triangle, the small triangle, the medium triangle, they all form the subtriangle. The part we have to remove from the whole. The whole as given in the question is 97. And the part is 74 as we saw now. 97 minus 74 is 23. So the squares are 23. Now let's continue to explore ways to compose new shapes using our tangram pieces. Can you draw two smallest triangles? What shapes can you make that you can name? Look at these ones. I joined two triangles together to make these shapes. Can you name them? I will use two triangles to form these ones. What is the name of the first polygon? How many parts are in this large triangle? Now there are two parts there. Are the parts equal? Yes, they are equal. So we can say that this triangle is made up of two equal shares or two equal parts called halves. If you share one into two, you have half of one. Half plus half equals 1. That is true. We share it in half. Now look at this polygon. What would you call it? Does it not look like a square to you? It is a square. Now, how many parts are in the square? I shared it into 2. Are they equal? Yes. Can we say that this square is made up of 2 halves? Yes, I joined 2 halves together to make this square. Now let's look at this other shape. What would you call the polygon? It has 2 pairs of parallel sides, so it's a parallelogram. Is it divided into halves? Yes. Now if I didn't make any of these ones, you can make like my own. Can we make halves by putting together a small triangle and a parallelogram? Question: how many halves makes a whole? 2 halves. Half plus half equals 1. 1 is a whole number. Now let's explore halves using pattern blocks. Look at the shape displayed now. Count the sides. It is a hexagon. It has 6 sides, 6 angles. What smaller polygon could we use to cover half of the hexagon? How would you cover it? You can try a trapezium. Just try. Which one would you use? Yeah, I use a trapezium. That's a trapezoid. A shape. It has 4 sides, 1 pair of parallel lines. This is the other half. We have covered the hexagon. So how many trapezoids make a whole hexagon? 2. We use 2. Are they equal? Yes, two equal halves. So how many halves are in the hexagon now? Two. Now let's look at a rhombus. What smaller polygon could we use to cover half of the rhombus? Look at it very well. We could try a triangle. That's how I feel. Well, what do you think? Yes, a triangle can do it. But this triangle, all the sides are equal, so we'll call it equilateral. Equilateral triangle. Equi means equal, lateral means sides. It has three equal sides. Now if you put on the other side too, it will cover the rhombus. How many equilateral triangles do you use to cover this rhombus? Two. Are they equal shares? Yes. So how many halves are in the rhombus? Two halves. Half plus half equals 1. Now this is a trapezoid. What can we use to cover this trapezoid? Let us try a polygon that can go into it like 3 times or so. Let's see. That's a triangle, another triangle, and yet another triangle to cover the trapezoid. So how many equal shares compose a whole trapezoid? 3. We use 3. We call 3 equal shares or 3 equal parts thirds. This is thirds. That is 1 over 3. 1/3. So work with your partner and then cover a rhombus and write out how many sides. This side that is open is now 1 over 3. It's now 2 over 3 that is open. We'll cover it with a rhombus. Now look at, I exchanged 2 triangles for a rhombus, and there's 1 triangle left. Question, can we call these halves? They are not equal halves. It is thirds, because when we share that rhombus, it will be 3 equal triangles that we put there. Now let's cover this polygon. What is the shape? You can count the sides and find out. Now I'm using a rhombus to cover the sides of this hexagon. There's another one and another to cover the 3 sides. So how many equal shares compose a whole hexagon? 3. What do we call 3 equal shares? Thirds. Now, can you make one large square that is created with equal parts? Try use shapes and see what you get. Now this is a square, another square, yet another square, and another. This is a large square. I use squares to make a large square. Are the parts equal? Yes. We call 4 equal parts fourths. This is 1/4. That is 1 over 4 fourths. All right. Now you're going to do some practice for me. You'll use puzzles, the tangram pieces to draw your solutions in each of these examples. When you're done, bring your work to class for marking. Bye.